starting.
Hi, my name is Farid. My project manager, Kenneth, Sarnes, Aung, Nguyen, Jian, Nguyen, Neon. We are the developers of the wireless indoor education system. My advisor is Professor Jajodia. As we all know, GPS works by tracking the satellite position and giving the location on the ground. The main problem with GPS is it does not work inside the buildings because it needs a clear side of view and a view of the sky. To overcome this problem, our project come in use. Wireless network. As we all know, like most of the buildings have wireless network installed in their environment. And wireless network have access point, which distributes the signal strength all over the floor, different floors. So our project is to get the signal from this access point and display it on the display the position, user's position on the screen. This is one of the examples. Once you get the location, you can tell the destination you input and your position as is on the screen as on the screen. This is a top level design. The only component which you need for your device to work is the mouse, wireless signal, keyboard to give the output as the location of the user. This is the architecture design which is more informative, which you need a wireless adapter installed in your device to capture the signal from the access point. And you need a database. You need a database to collect the access point strength, signal strength, and the MAC addresses. Floor plan is also essential for this. And to end this, we need a program to put all these together to display a user's location on the CPU or on the laptop.
We use a fingerprinting method to do our to locate in and try to get the put the destination. The idea of the fingerprinting method is the first you have to collect the collect the database and then we using NetSampler to compare all the database that you collected and with NetSampler to collect all the make a comparison. From from that comparison, if it's a match, we can find the location of the user. And since we are using Tefro as our project, so we collect all the data data from the Tefro from each location of the node, and we try to build the database. Well, we are using NetSampler to collecting the data. The NetSampler is that show us all the signal strengths and all the information of the access point. And also, NetSampler not only giving all the information, and also we can export all the information into the test file. So these are all the information of the data in the test file, and these particular one is like from these one of these data. And as you can see, there's a lot of information, but we in our project we only care about MAC address and signal strength. So we have to filter all the information that we are not use. And this is a complete idea of the database. as you can see that we collected was MAC address and signal strength from the nest sampler, and after that we added up row number, and then all the XY axis and high-low signal. Or with the database, the program we're going to be making comparison.
Now, all the information you need, you cannot get just from nest number. Actually three values you need to get by other means. One is the XY coordinate. We developed a special program for that allow us to display the floor plan and with a simple click of the mouse find any coordinate we need. The other is what we call the highest value number. This number we consider essential for our locating. It is created by searching the information for the highest signal strength and then assigning each of those, actually searching the database for the three highest MAC addresses with the highest signal strengths. Those MAC addresses are assigned numbers, that is numbers put together into a single number, and that's the highest value number. That number is then input that is compared. That number is then compared, and if that matches, then the MAC address and the signal strengths are compared. If they match within a given margin, then you have found their location. The location method was essential for our search class. It was needed in order to find location. Now, locating the destination is relatively simple. All you had to do was compare the room number to the database, and you had to get that location. Locating the user, however, was more complicated. It required two more specialized classes. One class was the run next number class, which when called ran a VB script file, which activated next number, ran it for a set period of time, and then saved the output to a file. After that, unfortunately, as you saw in the earlier slide, it's still not usable because it needs to be formatted. Another class was created to format it, and so it can be used by our search class. All these classes are essential, but they do not allow for interacting with the user, which is what the graphic user interface is for.
Based on the system design, we build the Wi-Fi indoor locating system. This is our interface for our for the system. I will explain how to use our system. The first, the user will click on the run and next number button. Then he will select the destination room number from drop-down list. Next, click on the user destination. Then click on the user location. Finally, the user location and the destination will pop up on the screen, which is just like that. You are here, which is the user location. If the user keep moving, right, he want to check in his current position, then he need to click on the run the next number button again. Then also click the user location again. Then you will pop up this screen again. The UI here will move update to the current location. When the user location and the destination location are the same, then we will have the screen will show that user will find the location. This is the device we use for our system. Next, we will show the video about our system using this device. This will show exactly how the whole system works. Now it keep that one, the window pop up. The next is our testing part. We stay in front of the destination. That's a 3914. This is the destination farm. The 3914. We also testing the different location. They are all success. Based on our last test, we found that there's a 70% of exact match for the user destination and the user current location. But we still have the 30% off by about 7 feet. Now it's less to the door now, less to the other room.
Now our project cost. We spent $310 for the hardcore. We also spent 390 hours work on the program. The total, which cost $6,950 for total cost. One detail. Here the contribution of each member in our project. Our project is divided into software, database, and hardware. Kenneth and Jian have responsibility on software. Aung is database, and me and Faisal in hardware. Lesson learned. We have learned a VB script on new program language. That program can be automatically run an application and save a file, delete update the file. Our project always have plan B. Actually, we use plan B in our project for running our program in the laptop instead of the device. In addition, teamwork is extremely important. A special thanks to Professor Jeffrey, Professor Zheng, and Professor Farid for all is in faculty who support us. Thanks very much.